All right, welcome back. Yesterday we talked about solving absolute value inequalities, and we looked at these two problems. Okay, so we saw that, where's my marker? We saw that the solution to this, again, this was an OR statement. We saw that the solutions were the numbers bigger than 8 or the numbers that were smaller than -2. And on this question, we saw that, well, this was an AND statement. We saw that our solution was the numbers between -8 and the numbers, or I should say, the numbers between -8 and -6. Okay, now, before we go to what all this means, let's just recap a little bit. Okay, so, reminder, to write our two statements, we said what? Again, can we make an A out of this? No. Okay, so we write x minus 3 is greater than 5. Notice not changing anything in the first statement, or, is our connective word, x minus 3, which does not change, and we flip the sign, less than -5. Okay? Down here, very similar, we write x plus 7 is less than or equal to 1. Okay, write exactly what you see, our connective word here. We can make an A out of this. This was the word and. Okay. On the second equation, x plus 7, and we flip the sign, so we get greater than or equal to -1. Okay. Now, what does this mean? Where does this come from? Okay, it comes from a simple logic. It stems from this, and I'd see if you can follow this logic as I show you this example. Okay, so we're going to start with something very basic. We figured it out. Okay, so it wasn't that, it's not or because I told you it's or. It's not and because I told you it's and. It's or because it stems from logic. Okay, it's and because this is the only logical connective word that makes sense. Watch. The absolute value of x is greater than 5. So let's look at this. Okay, so what we have to do is figure out what makes this true. Okay, so let's just look at it. And it's a matter of figuring it out. Then we're going to work and we're going to see what our connective word should be. Okay, and hopefully you say, well, that should be an or statement. We'll see that in a minute. Let's put a number on. So if we think for a moment, what makes that true? What makes that true? Well, does 5 make it true? Okay, so if we look, absolute value of 5, is that greater than 5? Nope. Okay, so we have 5 greater than 5. No, that's not true. Okay, so 5 does not work. So I want you to put 5 here. 5 does not work, so we're going to put, if it does not work, we're going to put open. So put an open circle. This does not means 5 does not work. What does work? What does make this true? Think for a moment. 6. 6 makes it true. Okay, so let's try 6. The absolute value of 6, is this greater than 5? Yes. Okay, because the absolute value of 6 is 6. 6 is greater than 5. Okay, so 6 is here. Does 6 make it true? Yes. So we're going to put it closed. Okay. Very similar to what I did in the last lesson with the concept of an infinite number of numbers. We're going to talk a little bit more about that. Okay, so let's look at the absolute. What else makes it true? Well, 7, again. Absolute of 7 is greater than 5. Yes, 7 is greater than 5. That's true. So we're going to put a closed dot at 7. Again, we're getting out of the, okay, we've got to move out of elementary school, middle school mentality, and we're moving into now high school thinking. Okay, so no, not just 6, 7, 8, 9. Let's get out of that. Let's think, how many numbers are there between 5 and 6? Okay. Wow. Okay, we talked about this yesterday. Does 6.1 make it true? Yes. The absolute of 6.1. The absolute of 6.1 is greater than 5. Yes, this is true. Okay. Does 5.1 make it true? Yes, 5.1. Absolute of 5.1, is this greater than 5? Yes, because 5.1 is greater than 5. Yes. Okay, does 5.1 work? Yes. Does 5.2 work? Yes. Does 5.3 work? Yes. Okay, so we start to see there's a lot of numbers. Does 5.01 work? Yes. Does 5.001 work? Yes. And so on and so forth and so on and so forth. How many numbers make this true? Wow. Okay, lots. Okay, so let's look. So we say 5.1, 5.2, 5.3, 5.01, 5.001, 5.0001, 5.23, yes. 5.223, yes. 5.2222223, yes. Okay, 5.5, yes. 5.51, yes. 5.511, yes. Okay, so, wow, how many numbers make this true? Infinitely many. But what's happening? The points are stacking closer and closer and closer together. Let's talk about a point for a minute, okay? If you've had geometry, maybe you've seen this before, but I'm going to put a point. I'm going to make it big enough so the camera can actually see it. But here's a point. Okay, so there's a point. And a point represents a specific location in space. Okay, so one point, one location. Okay, there's the point. Okay, so what does it represent? Okay, so we get close. We get very close to the point. What happens? When we get very close to the point, what happens? The point moves away. And the closer you get to the point, what happens? The point moves away. You put it under a microscope. Watch here. Okay, so here's your point. Now, hopefully the camera can pick this up. Let me make it smaller. Okay, so, okay, I get even closer. Okay, I get even closer. And what happens? The point moves away. That's very small. Okay, there. Yeah, there it is. I don't even know if the camera can see it, but extremely small. Okay, so really close. Okay, we zoom way in. Okay, way in. What happens? What happens? The closer you get, what happens? The point moves away. Okay, so a point represents a specific location. Okay, but the closer you get, it moves away. Okay, so the concept is there any width to a point? No. Okay, a point has no width. It's dimension. There's no dimension to a point. Okay, there's nothingness to a point. Okay. But it does represent a specific location. Okay, so that's weird. That's wow. Okay, that's okay. But what happens? Watch this. Watch this. Okay, so these points that have no width, no width. Okay, what happens when we put infinitely many points? Okay, infinitely many points stacked infinitely close together. Infinitely many points. Oh, what happens? We get a solid line. We get length. What? Yep. What happens? We get length. So you stack infinitely many. Okay, the real numbers are dense. Okay. I don't have my chart in front of me, but in class we do a pi. We look at the pie chart. The pi 3.141592665. Okay, this goes on and on and on and on and on. Okay, this goes on and on forever. Never stops. Never stops. This number goes on and on and on and on and on and on. Okay, we write millions and millions of digits of this number, and never can write this number. Is pi 3.14? No. Is pi 3.141? No. Okay, no computer, no human will ever be able to write this number. But you write all of these digits, and way down here there's a 6. Way down here in the string of digits you have a 6. And if you change that 6 to a 5, you have a completely different number. You know, way further down, a million digits further, you have a 7. And if you change that 7 to a 2, you have a completely different number. Okay, so how many numbers are there just next to 3.14? Wow. Okay, blows your mind. We say that the real numbers are dense. Okay, there are so many numbers you can't even begin to comprehend. Okay, so how many numbers are there between 5 and 6? Okay, there's as many numbers between 5 and 6 as there are all real numbers. Okay, that's weird. Okay, we call this the cardinality of a set of numbers. How many numbers are in a set? Cardinality. Okay, we can show that the real number system is dense. Okay, this number line, we call it the x-axis, represents the real number system, all numbers. Okay, and there's so many of them. Okay, so when you see this, what do you think? Oh, wow. Okay, wow, that's a lot. But what happens? Okay, so we stack infinitely many numbers. Infinitely many numbers, represented by points that have no width. Stacked infinitely close together, form length. We have a line. How does that make sense? That's weird. Okay, but look, here's a line. Here's a line. Does a line have any width? Does a line have width? No. Okay, line has no width. Why? Because it's made up of points. Look, here's a line. Okay, hopefully the camera can pick this up. Okay, so, there's a line. Okay, the closer we get, the line moves away. There's no width to the line. It has length, but there's no width because it's made up of points. Okay, try to, well, you can't really wrap your mind around it, but you can try to, the more you think about it, the harder it gets. Okay, but notice, back to this. What numbers make this true? Well, we say the numbers that are what? The numbers that are what? Greater than 5. Okay, now, what else makes it true? There's more. Okay, there's more to this. Hopefully you see this is all the numbers greater than 5. That's wow. Okay, what else makes it true? Here's negative 5. Okay, here's negative 5. Well, hopefully you see 0. Does 0 make it true? Does 0 make it true? Does 0 make it true? No. Absolute value 0, is that greater than 5? No. Okay. So hopefully you see 0 does not make it true. Open circle does not make it true. Now question, does negative 5 make it true? Okay, absolute value negative 5. Is that greater than 5? Well, the absolute value negative 5, make it positive. Is 5 greater than 5? No. Okay, so we see that negative 5 does not work. That's open. Hopefully you can see all the numbers between negative 5 and 5 will not work. Okay. What about less than negative 5? Here, let's try some numbers that are smaller than negative 5. What about negative 6? Does the absolute value of -6 make it true? Does -6 make it true? Yes. The absolute value of -6, is that greater than 5? Yes, because make it positive, 6 is greater than 5. Yes, that's true. So -6 works. -7, obviously you start to see -7 works. Okay, what about -5.1? Yes, okay. -5.2, yes, and the same analogy. Okay, so we say what? All the numbers that are less than -5. So we see we have two pieces. Okay, now notice I have not talked about a word or. Okay, I'm just showing you what this means. We're going to represent this set of numbers, okay, as the numbers that are greater than 5. We're going to represent this set of numbers as the numbers that are less than -5. We need a connective word. Okay, so I'm going to show you that the connective word that works here is or. Okay, because somehow we have to join two sets. Right? Here, this is the analogy. So here's the logic. Okay, so if your parents tell you, all right, we're leaving to go to the store. While we're gone, you're to take out the trash or sweep the floor. Okay, so while your parents are gone, they tell you that you have to either take out the trash or sweep the floor. Now, they get back home, and you took out the trash, but you did not sweep the floor. Okay, are you in trouble? Okay, hopefully you say no. Okay, why? Because or means do what? Do one or the other. Okay, one or the other. Let's write that. Okay, so or, we said greater than or equal to is or, means one or the other. Logically, that's what it means. Okay. Less than or equal to meant what? And. Now I want you to write and means what is common. Okay, and means what is common. Now let's start with or. One or the other. Okay, let's listen. Okay, so the numbers here have to satisfy the statement. Let's go ahead and put the word or, and I'm going to show you that this works. Okay, so we're going to pick a number. Pick a number. Okay, one or the other. So your answer has to satisfy one or the other. Pick a number. How about 6? Okay, now listen to what I'm saying. Okay, is 6 less than -5? No. Or is it greater than 5? Yes. Yes. Why? Because that says 5. Listen again. Okay, is 6 less than -5? No. Or is it greater than 5? Yes. Does it satisfy the entire statement? Yes. Why? Because we have a connective word, or. It means one or the other. The solution has to satisfy one or the other. Pick a number down here. -7. -7. Is -7 greater than 5? No. No. Or is it less than -5? Yes. Okay, so does -7 satisfy one or the other? Yes. Okay, so hopefully you can see that the logical connective word here is or. All right, now, these two statements that I told you to write, this is also shown here. Okay, so we're going to draw an arrow. Okay, down. Okay, now, notice the absolute value of something is greater than 5 means what? We wrote it here. We figured this out not because I told you, but rather here. We just looked at it, and we figured out what our answers had, what values of x would make this true. So this is not because I told you this. This is what resulted from the original statement. So look, absolute value of something is greater than 5 means what? That something is greater than 5. Notice nothing changed on the first, or the same thing is less than its opposite. What did we do here on the second statement? So what should we do? We should what? Flip the sign. Flip the sign. So the absolute value of something is greater than 5 means what? That something is greater than 5. Or that same thing is less than its opposite. Or flip the sign. Flip the sign. We had greater than, now less than. We had positive, we have now negative. Okay, so that's where this is coming from. Okay, now let's look at and. All right, quickly. It's the same setup. Okay. We're going to look at the absolute value of x is less than or equal to 5. Okay. Now I've already told you that we can make an a out of this, so this is an and statement, but let's see what happens here. Okay, so first off, we're going to figure out what would make this true. What would make this true? Let's see. Question. Would 5 make this true? Yes, because we have less than or equal to. The absolute value of 5 is that less than or equal to 5. Okay, absolute value of 5 is 5. So is 5 less than or equal to 5? Yes. Okay, this is true. So here's 5. Does 5 make it true? Yes. So 5 is a solution. Put a closed dot. Okay. Does 6 make it true? Does 6 make it true? Here's 6. Does 6 make it true? No. Okay. Why? Because the absolute of 6. Is the absolute of 6 less than or equal to 5? Is 6 less than or equal to 5? No. Okay. So does 6 make it true? No. Put in an open circle. This means it's not a solution. It is not included. Okay. Now, here. Does negative 5 make it true? Yes. Let's look. Here. Absolute value of negative 5. Is that less than or equal to 5? Yes. Why? Because the absolute of negative 5 is 5. 5 is less than or equal to 5. That's true. That's true. So does negative 5 make it true? Yes. Put a closed dot. Okay. Does negative 6 make it true? Does negative 6 make it true? No. Okay, let's look. Absolute value of negative 6 is less than or equal to 5. Is that true? May appear to be, but let's look. Absolute value of negative 6 is 6. Is 6 less than or equal to 5? No. Okay, that's false. Okay, so what do we have? Open at negative 6. Now, so nothing here, nothing here. We see 5 works. We see negative 5 works. Let's look at the numbers between negative 5 and 5. Here. Does 0 work? Does 0 work? Yes, it does. Look, absolute value of 0. Is that less than or equal to 5? Yes. 0 is less than or equal to 5. So does 0 work? Yes. Okay. Does 1 work? Here's 1. Does 1 work? Yes. Absolute value of 1. Is the absolute value of 1 less than or equal to 5? Yes. 1 is less than or equal to 5. Yes. 1 works. So put a point here. And you start to see very quickly, does negative 4 work? Yes. The absolute value of negative 4 is less than or equal to 5. Yes. 4 is less than or equal to 5. Yes. Negative 4 works. And again, does 0.1 work? Yes. Does 0.2 work? Yes. Does 0.001 work? Does 0.5 work? Yes. Okay, so how many numbers are there here? Wow, infinitely many. And we are going to represent the numbers as everything between. An infinite set of points, or an infinite number of points that have no width form what? A solid line. Well, technically we call this a line segment because it does not go on forever, but still. How many numbers are in this set? Wow. As many numbers in this set as there are all real numbers. Wow. So there's as many numbers here as there are on the entire number line, guys. That should blow your mind. Okay. So now let's see what happens. Okay. So we have to now figure out what satisfies the solution set. Well, let's erase the open circles. That's not part of the solution. That's not part of the solution. There's your answer. The answer is here. Okay. All right. Let's do it like this. So we see that the solutions are the numbers. I'm going to erase this so it's very clear. Okay. We see that the solutions are the numbers where? The numbers that are between negative 5 and 5. But how do we say that? Watch. Okay. We're going to say, well, it's very hard to say this, and that's where the word and is going to come in, but watch. Okay, so less than or equal to 5. Okay, closed to the left. Okay, greater than or equal to negative 5. Okay, closed to the right. How do we say the first one? Less than or equal to 5. All numbers that are less than or equal to 5. Write that. All numbers that are less than or equal to 5. The top one is all numbers greater than or equal to negative 5. Okay, so again, the first statement here represents the middle. The numbers that are less than or equal to 5. This statement here represents the top, okay, the numbers that are greater than negative 5. Do you agree that together these two are too much? Now, I'm going to erase the actual answer for a moment. We know that our answer are the numbers between negative 5 and 5. I'm going to put this down here at the bottom. We know that this is the answer, the correct answer. But somehow we have to make these two become that. Okay, somehow these two have to become the correct answer. Okay, so this is the word we're going to use. Okay, I'm just going to show you. Obviously, I think you already have caught on to this. That well, obviously, the word is and. Okay, the word that we're going to use is and. I'll show you. Okay, what does and mean? And means both. And means what they have in common. So if your parents leave, and while we're gone, you have to take out the trash and sweep the floor. Okay, so they say take out the trash and sweep the floor, and they get home and you just took out the trash but you did not sweep the floor. Are you in trouble? Yes. Why? Because and means both. Do both. Or in math we say it means what is common. Okay, so I think you'll see it. Watch. Watch. Okay, so and means both. It has to satisfy both. You have to take out both the trash and you have to sweep the floor. So let's look. Okay, so looking up top. Okay, so we want to get rid of what? We want to get rid of this tail, and we want to get rid of this tail. Okay, before we wrote the word and, what do we have? Too much. Okay, we have the entire number line. We have everything to the right, everything to the left. How do we get rid of this tail and this tail? Well, that's the word and. And is going to work. Watch. Okay, so let's look. Well, let's put here's the 6, and here's the -6. Okay, now, my question is 6, now we know that 6 is not an answer, is 6, okay, the word and, compress this, is 6 greater than -5? Yes. And is it less than 5? No. Okay, do you see the logic? Is 6 greater than -5? Yes. And is it less than 5? No. Okay, do you see that 6 is not a solution? Why? Because it must satisfy what? Both. Okay, let's look at -6. Okay, is -6 less than 5? Yes. Okay, and is it greater than -5? No. Okay, so let's look at the numbers between. Okay, let's look at that. Let's 0. 0 is between -5 and 5. 0. Is 0 less than 5? Yes. And is 0 greater than -5? Yes. It satisfies what? Both. So we see what? We see that 0 works. Okay, we see that what is 1? Let's look at 1. Okay, is 1 less than 5? Yes. And is it greater than -5? Yes. So 1 works. And you're going to find that all of the numbers, you can test any number you like, all of the numbers between -5 and 5 work. What numbers do not work? Well, 6 does not work. Okay, so let's try this again. Okay, so here, what happens here? Let me show you. What happens? Okay, so 6. Is 6 greater than -5? Yes. And is it less than 5? No. So what happens? All of these go away. Okay. And now -6. Is -6 less than 5? Yes. And is it greater than -5? No. So what happens? All of these numbers go away. And what are we left with? We're left with what these two have in what? What these two have in common. Okay. So the answer is all numbers between -5 and 5 inclusive. Now, looking here, okay, this is where this statement comes from. Okay, so I told you to do this yesterday, but let's see it now. Okay, so the absolute value of something is less than 5 means what? It means that something is less than 5. Notice nothing changed. And the same thing is greater than its opposite. So what happened? We flipped the sign, and we flipped the sign. So the less than became greater than, the 5 became greater than 5. Okay, so again, the absolute of something is less than 5 means what? Something is less than 5, and something is greater than its opposite. So there you go. That's why we're doing this. Okay, so there is your explanation of why for the and the or. Now, let's look at some problems before we conclude this video. Some harder problems. I'm going to take. You're on page 45 of your book. I'm going to take number 10. And change it a little bit, make it a couple steps harder. Okay, so 14 minus 3 is less than 4. Here, let's erase this. And let's write the problem. Absolute value of 14 minus 3. Let's make this -3 is greater than or equal. Let's see. Is greater than or equal to -21. No, that's not going to work. -7 is greater than or equal to -28. That should work. Yeah, that's the same. Okay, so this is our problem. All right, now, just like with equality, notice this is a little different than what we looked at yesterday. Notice the first thing, we talked about this with equality. Is the absolute value isolated? The answer is no. Here's the division of the equation. Okay, this divides the equation into 2 halves. Okay, the absolute value is on the left. Is it by itself? No. Okay, so the first thing you have to do is what? The number one thing, it's the same with the inequality as it is with equality. Number one thing is what? Isolate. Isolate the absolute value. Okay, so we have to isolate. That means we have to get rid of what? We have to get rid of -7. We have to get rid of -3. Okay, we start with which one? Okay, the 7 is being subtracted, the -3 is being multiplied. So we're going to start with what? The addition. Okay, so we're going to move the -7 to the right. What's it going to become? +7, cross it out. We end up with -3 times the absolute value. 4t minus 3 is greater than or equal to -28 plus 7 is -21. Now here's something where students get confused. So looking at the original statement, looking at the original question, is this and or? Is this and or? Now this trick that I showed you, well I should say, let me tell you, this is a trick, okay? This is a trick, and it only works in specific cases, guys. It only works when the absolute value is isolated and on the left. This little trick of making an A out of it works when the absolute value is isolated on the left. But when do we check? We check for and or when this thing is isolated. The question is this an and statement or an or statement? Okay? If you said an or statement, that's wrong. This is actually an and statement. So I tell students this. Okay, is this and or or? Is this and or or? We don't know. Okay, so you say, I don't know until it is isolated. So you wait until it's isolated before you check. Okay, so we got rid of the -7, it became +7. Now what do we have to do? We have to get rid of the -3. Since -3 is being multiplied, we're going to divide. Divide by -3, divide by -3, and when we divide by a negative number, okay, divide or multiply by a negative number, the inequality sign flips. So we end up with less than or equal to -21 divided by -3 is 7. Okay, we have the absolute 4t minus 3 is less than or equal to 7. Here, stop. Okay, there's your stop. Stop here and check. Is the right side positive, 0, or negative? Okay, the right side is positive. So what this means, and I haven't really gotten into this yet. I will in the next lesson. Okay, if this is 0 or this is negative, weird things start to happen. Okay, so for right now, it's positive, and for the test, it will be positive, so you can just kind of rest these. Positive basically means the solutions make sense, okay? Now, before I go on, maybe explain that a little more. Absolute value of x is equal to a positive value. Absolute value of x is equal to 0. Absolute value of x is equal to a negative number. This is all different. Notice, this is equality, equality, equality. We're looking at inequality, completely different. Okay, so absolute value of x was equal to a positive value was what? 2 solutions. Okay, absolute value of x is equal to 0 was what? 1 solution. Okay. Absolute value of x was equal to a negative number is no solution. Okay, so with the equality, you can either have 2 solutions, 1 solution, or no solution. Okay, with the inequality, we're looking at infinitely, I can't spell, I-N-F-I-N-I-T-E-L-Y. I think it's with an E. I'm horrible at spelling. Okay, so I asked my kids, how do we spell infinitely? Okay, so infinitely many solutions. You know, as you get older, the mind gets old, you forget. Okay, so infinitely many solutions. If I make a mistake on the board, guys, I apologize. In class, the students correct me. Okay, so if I, oh, that's wrong. Okay, so we fix it. But if I make a mistake, and I do, okay, so if I make a mistake, just know that I'm human just like anyone else, so sometimes mistakes happen. But I try to make these videos as precise as possible so there's no mistakes, not to confuse you. All right, but infinitely many solutions. Now, in this case, positive 7 means there are going to be infinitely many solutions. If we get something like 0 or negative, weird stuff starts to happen. Could we have 1 solution? Yes. Okay. Could we have no solution? Yes. We'll talk about that later. But let's look at the difference. Again, equality, you either have 2, 1, or no solution. Okay. With inequality, for the test, you have infinitely many solutions, and this has to be represented 3 different ways. Okay. So now let's look. Don't get confused between equality and inequality. The absolute value of 4t, well, we're running out of space. Here, I'll write it here. Okay, so the absolute value of 4t minus 3 is less than or equal to 7 means what? We write 2 equations. What's on the inside does not change. 4t minus 3 is less than or equal to 7 and or. And or. The word is what? The word is and. Okay? Since this is less than, we can make what? An A out of it. Notice it changed. Again, we check when it is isolated. And what? 4t minus 3 does not change. 4t minus 3, flip the sign. So greater than or equal to what? Negative 7. Okay, now we solve these. I'm going to move very quickly here. I assume you guys know what we're doing now. Add 3, we get 4t is less than or equal to 10. Okay, divide by 4, t is less than or equal to what? 10 over 4. Can we reduce this? Yes. Okay, we divide them each by what? 2. Okay, so 10 divided by 2 is 5. 4 divided by 2 is 2, so we end up with 5 over 2. This is not acceptable. Now we ask, how many times does 2 go into 5? How many times does 2 go into 5? Well, twice. Okay, so 2 goes into 5 twice, put it 2. Okay, and how many are left over? Well, 2 times 2 is 4, and 5 is 1 more, so there's 1 left over. So we have 1 over 2. And, okay, we're going to be doing this so much that I'm not really worried about it. If you're struggling with this, we're going to be, trust me, reviewing this many, many times. Here, add 3, okay? So we have 4t is greater than or equal to negative 4. Divide by 4, t is greater than or equal to negative 1. Now with and statements, said yesterday, what do we have to do with and statements? We have to compress, okay? So we're going to combine this as one statement. Remember, variable t is between, okay? Between what two numbers? Your critical values. Your smaller number to the left, larger number to the right, 2.5 goes to the right. Signs always point what? Same direction, to the left. If you forget, look here. T is less than or equal to 2.5. Okay, this statement matches this statement. Greater than or equal to negative 1. Notice it's pointing towards negative 1. It is still pointing towards negative 1. So looking here, looking here. Okay. All right, now, the solution set has to be represented in 3 ways. So we're going to say first, number line. Okay. Critical values are what? Negative 1 and 2.5. Negative 1, 2.5. Okay. Open or closed. Hopefully you say closed at negative 1. Closed at 2.5. Okay. And we read this as what? T is between negative 1 and 2.5, so we're going to connect here. Okay. Everything between negative 1 and 2.5. Next, inequality notation. I'm not going to really re-explain a whole lot here. I think the last video does a good job of that. If you need to re-watch them in a different order, do that. Inequality notation says, make this fancy. So we're going to put a brace, okay? Variable is what? Variable is t, so t such that t follows this rule. Rewrite this. Negative 1 is less than or equal to t is less than or equal to 2.5. Or better said, we say this as t is between negative 1 and 2.5. Now close the brace, okay? Lastly, interval notation. Remember, interval notation is what? Left to right, left to right. So we're going to read left to right. Nothing out here, nothing, nothing, nothing. Where does it start? Well, the numbers that make it true are the numbers between negative 1 and 2.5. So where do we start? We start where? Negative 1 up to what? Up to 2.5. Do we include the negative 1? Yes. So what are we going to use? Bracket. Okay. Do we include the 2.5? Yes, it's closed. So we're going to use bracket, and there's your answer. Okay, so this is about the hardest you're going to see on the test, something like this. Okay, remember when you divide, going back to this, when we divided by the negative number, what happened to the inequality sign? It flipped. Okay, now, one more and we're done with this video. Okay, so one more. The next question will be like number 18. Like number 18. Okay, so I'm going to make number 18 in your book just a couple steps harder. Okay, so 2 comes out to about 3x minus 4 plus 7 is greater than 27. I believe that should be the same. Yeah. Okay, so the first thing we have to do, it's written right here. First thing we have to do is what? Isolate. Isolate. That means get rid of what? Notice here's your absolute value. I mean isolate this unit. Okay, we have to get rid of what? Get rid of 7 and get rid of what? 2. Okay, now, notice 7 is being added, 2 is being multiplied. Which one do we start with? Well, hopefully you say 7. We start with what's being added. Subtract 7, cross it out. 2 times the absolute value, 3x minus 4 is what? Greater than 27 minus 7 is 20. Hold on, question, is this and or or? Is this and or or? Is this and or or? Hopefully you're saying, what you're supposed to say is what? I don't know yet. I don't know why, because the absolute value is not isolated. When do we check for and or? When do we use this trick? We use this trick when the absolute value is what? When the absolute value is isolated. Now, as time goes on, as the semester goes on, you're going to be able to look at this thing and tell me immediately is this and or. You will see that when we divide by a positive number, nothing's going to change. So this looks like an or statement. In fact, this is an OR statement. Okay, so we'll see when we isolate. Divide by what? Divide by 2, divide by 2. So for the test, I want you guys to be saying, okay, we're not going to check until it is isolated. Divide by 2, we have 3x minus 4 is greater than what? 10. Okay? Yeah, that's the same as the problem. So this was the problem in the book. You see, this is 2 steps harder. Now, question, is this isolated? Yes. Now check the right side. Is the right side positive? Yes. Still stop and check. Okay, still stop and check. Right side's positive. What this means is we have infinitely many solutions. We don't have any problems. Okay, when this is 0 or negative, things get weird. Okay, we'll talk about that later. Okay, greater than. Okay, we stop. It's positive. We have infinitely many solutions. Is this and or is this or? Hopefully you say or. Okay, we're going to write 2 equations. When we have 3x minus 4 is greater than 10. Connective word is or. 3x minus 4, flip. So we're going to flip the sign. Less than what? Negative 10. Okay, flip the sign. And now add your 4. 3x is greater than 14. Divide by 3. X is greater than 14 over 3. Now, if you're struggling with what we did last time, how many times does 3 go into 14? Well, hopefully you say 3 goes into 14. We're going to write x is greater than. 3 goes into 14 4 times. How many are left over? Well, 4 times 3 is 12. And 12 is 2 less than 14, so we're going to say 2 are left over, 2 over 3. Here, if you're struggling with this, again, 14 divided by 3. How many times does 3 go into 14? 4 times. 4 times 3 is 12. Subtract, we get what? 2. 14 minus 12 is 2. This is our remainder. Okay, so we're going to write remainder 2, and 2 goes over the 3, so we get 4 and 2/3. Okay, so that's one last time very quickly. Okay, it's 4 and 2/3. Now here, add 4. Okay. 3x is less than, negative 10 plus 4 is negative 6, divide by 3, x is less than, negative 2, and our connective word is or. Now, do we compress an or statement? Do we change this like we do an and statement? No, we leave it alone, okay? It has 2 pieces. Now, 3 ways. First, number line. Okay, number line, here. Critical values are at 4 2/3, negative 2. Here is negative 2. Here is 4 2/3. Okay, and we say x is greater than 4 2/3 means what? Open or closed? First, open or closed? Well, greater than is open. Open at 4 2/3, and greater than 4 2/3 means to the right. So to the right. Okay, less than negative 2 is open to what? The left. Now, hopefully at this point you guys are starting to notice or statements. Here for your test tomorrow, you can think like this. This is an or statement. Okay, notice or is going opposite directions. This is an and statement. And means what? Could be open or closed. Means what? Between. Okay, so this is an and statement. This is an or statement for your test tomorrow. Can this be different? Yes, we're not getting into that right now. So for right now, you're thinking or means going opposite directions, and means what? Between. Okay, so or statement, going opposite directions. Is this consistent with your connective word? Yes. Now, next, inequality notation. Okay, inequality notation says we want to write this fancy. Okay, so we're going to say, put your brace, your variable is what? Variable is x, such that, rewrite this statement. X is greater than 4 2/3, or x is less than negative 2. Close the brace. Okay, next, interval notation. I start writing sloppy when I write fast, but hopefully you already have yesterday's. Okay, interval notation. We read what? Left to right, left to right. So question, left to right. What are solutions? Okay, what's the idea? Is negative 5 a solution? Yes. Is negative 100 a solution? Yes. Is negative 1,000 a solution? Yes. Forever left, forever left. What's that idea? Forever left. That idea is what? Negative infinity is the concept of forever left. It's an idea, it's not a value. And over here, forever right, 4 2/3, above 4 2/3 is what, 10, 100, 1,000, a million. Okay, forever right is what, positive infinity. Again, they look like sideways 8s. So we say the solution set comes from what? The concept or the idea of negative infinity up to what? Up to negative 2. So from negative infinity up to what? Negative 2. Always parenthesis next to negative infinity. Question, open or closed at negative 2? We are open, so we have parenthesis. What if this were closed? If this were closed, you would have what? You would have bracket. Okay, so just be careful. Make sure you're paying attention. This is open. What does that mean? That means that 2 or negative 2 is not a solution, but everything below negative 2, for instance, negative 3. Okay. Now, since it's open, we're going to put what? Parenthesis. And where does it start up again? We have a break in the graph. Starts where? 4 2/3. Okay, so here's 4 2/3. open or closed. It is open, so we're going to put a parenthesis up to what? Forever to the right is positive infinity. Always parenthesis next to your positive infinity or negative infinity. Why? Because it doesn't make sense to include an idea. Okay, this makes no sense. Include negative infinity. Okay, well, if you include negative, what is negative infinity? Negative 1 million? Okay, well, if you include negative 1 million, what about negative 1 million and 1? Okay, so there's always one beyond. This makes no sense. Okay, so negative infinity makes no sense. So we always put parentheses, meaning you can't really include this. This is an idea. Okay, but it's forever to the left. Now, to join two things is one, what do we use? We use the union symbol. This is a U without a tail. It joins this set and this set as one set. Okay, now, so you have seen several examples. And, all right, that concludes this lesson. Your test will be very straightforward. So it's going to be, your questions are going to be just like this. Okay, after the test, we will get into more complicated types of questions. All right.